15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on the podcast known as Space Nuts. My name's Andrew Dunkley, your host, and with me as always, Fred Watson from the Australian Astronomical Observatory. Hi, Fred.
Hello, Andrew. How's your inhaling going today?
It's labouring. I'm getting much better. I'd consider myself at 90-95%.
After the flu.
Yeah.
Of course. That's what it means.
It's a real hanger-oner. And as you go into winter in the Northern Hemisphere, be warned. If you can get a flu shot, get a flu shot. I am serious. You do not want this. Now, today, Fred, we're going to be talking about an astrolabe. And that's all I know. Apparently, they found it in a ship that sank. And we're going to be hearing about Paul Weitz. Now, Paul was a Skylab and shuttle astronaut. Sadly has passed away, but what an amazing career. And we're going to answer a question today from John Milton, who's asking us about the Dyson Sphere and Tabby's star. So we'll get into that for you, John, a little later. But first, let's talk about the Astrolabe. Now, I did actually read about this yesterday, so I know what we're talking about. But it is a quite unusual find and quite rare, I would imagine.
It is indeed. So this is it's something that has been excavated from a shipwreck, an ancient shipwreck off the coast of Oman in the Middle East. And the thinking is that this is the earliest example ever found of one of these devices. It's called an astrolabe, but one that's specifically used for navigation, for marine navigation. It's a mariner's tool. Because, and the reason I say that, and we might preface our remarks on this topic with a little bit of history here.
Yes.
So an astrolabe is basically a device. It's usually in the shape of a brass disc with calibrations on it, with a kind of sighting or a pointer on it, which you line up with the star. So you kind of hold the disc up in one hand so that it's in the vertical plane, and then you point the bit that's pivoted towards a star. And you can read off the height of the star. And that's the basis of an astrolabe. There are other aspects to it too, because you can use them for finding stars as well. But that instrument actually dates back, I think the earliest record found of one is in the 9th century. And there was a lot of Middle Eastern astrolabes made. They were made by basically Islamic scientists in the 10th and 11th centuries. So those astrolabes are used for scientific, or were used for scientific purposes. This one that's been found in the ocean is much later than that, and it's fairly accurately dated at between 1495 and 1502 when it was made. But the reason why it's exciting is because it was used for navigation. It was a mariner's astrolabe rather than one that's used by scientists for, working out the positions of stars and things like that. So that's the bottom line. What is it? Well, once again, it's a brass disc, very highly corroded. It might actually be copper, actually, looking at the
it's hard to tell, isn't it?
Images that I've seen. But the history is really interesting because this ship actually sank in 1503, and it was one of the fleet of Vasco da Gama, the Portuguese explorer, who was an explorer. So he was doing his thing. The particular ship that we're talking about was called the Esmeralda, which is a name I love. The Esmeralda went down during a storm 1503. So that sort of dates, that's the latest date this astrolabe going to be made. Actually, you could probably say 1502 because they'd been at sea for quite a while. But the really interesting bit, and the reason why you can be fairly precise about the earliest date that it could be made is because of the markings on it. So yes, it's got the degree angles on, which apparently were revealed by laser processing at the University of Warwick in the UK.
Yeah, because you can't see it with the naked eye. It's so corroded.
That's
but
right.
the technology of today can reveal these hidden things.
it is astonishing what you can do with this kind of thing, and I've seen examples of this sort of thing before. Ancient mechanisms being dissected by lasers and computers, and X-rays too. In fact, in some cases, this one was done by laser scans, though, as I said, at the University of Warwick. And one of the things, well, it certainly revealed the graduations, but there are emblems on this astrolabe as well, and one of them is the personal emblem of Don Manuel I, who was the King of Portugal at the time. And he ascended to the throne in 1495. And so the thinking is that his royal emblem would not have been placed on the astrolabe if he wasn't king. So the thinking is that when this astrolabe was made, he was the king, and that dates it after 1495. The boat sank in 1503. So you've got a fairly narrow window of when this thing was made. So it's probably a pretty new device when it was carried on board the ship.
Yeah, and it would have been considered high tech in those days, I imagine.
Absolutely, yeah, very high tech. It's, as I said, astrolabes go back 500 years before this, but to have one that is for marine purposes, it's very interesting. It's, as I said, probably the earliest known.
So it would have been used to assist with navigation, I suspect.
That's right, yeah.
And so that using the measurements from the astrolabe, they would have been able to figure out where they were or where they were going, but how accurately?
Pretty accurately, actually. In terms of latitude, that's the great thing about an astrolabe. You can use it to measure, well, the height of the sun or the height of a star above the horizon, either at noon in the case of the sun or at the highest point in the case of a star, which is kind of like a star noon. And once you've made those measurements, certainly as far as stars are concerned, that immediately gives you your latitude, because if you know the position of the star in the sky, you measure its height above the horizon, that tells you your latitude. Longitude's a trickier thing to work out, and as I'm sure you know, it was another more than 200 years before the problem of finding
figured it out.
That was done by chronometers. So it was John Harrison, the Englishman, who perfected the chronometer. And I think about 1760 was when his final chronometer was made, that really solved the problem of longitude properly. But before that, longitude was an iffy thing. And of course, that comes about because the Earth's rotating. So you need to know the time accurately before you can make any measurements. And if you don't know that, you've got this, you do have some idea, but it's a very high level of error. But latitude is different. Latitude's easier to find, and an astrolabe will do that for you. And by the way, just a footnote to what I was saying before, it's made of bronze.
Bronze.
That's the material of which it's made. Yeah.
Now, the other interesting thing in terms of seafaring navigation, the Vikings didn't use an astrolabe, as far as I know, but they did use a thing called a sunstone to navigate.
That's right, they did. Which were basically, I think the sunstones were magnetized stone that pointed north. I think that's right. There is something else though about a sunstone that's in the back of my mind, and I can't think of what it was.
But not sure, but I think they could hold it up to the sun on a cloudy day, and it would enable them to see the disk of the sun through the clouds or something like that. And
that's right. I do remember I've certainly read about this. I do remember the idea of it being useful on cloudy days, but I think it's because they were magnetic.
Yeah, maybe you're right.
And so it sort of basically, instead of seeing the sun, it lets you see which way north is. Yeah, the Vikings were a clever bunch as well.
This is the thing. These sorts of finds show you that the people of hundreds or even thousands of years ago were not dumb. I mean, they had some pretty high-tech concepts that they worked with. It's only technology of today that makes us think we're more clever, but we really aren't. We've just got better tools. But
that's correct.
They had it all together.
And in fact, something I kind of obliquely alluded to a couple of minutes ago when I was talking about X-raying ancient mechanisms, and we should talk about this on Space Nuts sometime. That's the Antikythera mechanism. And so this is something that was found off Alexandria, the bottom of the Mediterranean, dated at about 0 BC, or 0 AD, and it's basically a planet simulator. It's full of gears. It's highly corroded.
Yes, I've heard of this.
But but X-rays revealed that it's got all these toothed wheels inside it, which actually give you an indication of the position of planets. It's an extraordinary thing, and it's 2,000 years old. It really is staggering stuff. That kind of engineering at that time, of course, gives rise to all kinds of conspiracy theories, which we won't touch on just now.
No, but definitely worth talking about in a segment all on its own down the track. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, we're going to reflect on the life and times of a US astronaut. Paul Weitz is his name. He was a retired astronaut, has now passed away, according to the news, at the age of 85. But what can you tell us about him?
Well, he was very accomplished, and one of these guys who you don't hear much about, but when you look at his record, he achieved a staggering amount in the world of astronautics. He actually, when you think of that great clutch of astronauts who were in the Apollo era, he was part of that. He joined NASA in 1966, but I think his first mission was 1973, and it was to the Skylab spacecraft, which was a US space station, a sort of forerunner of the International Space Station. So Skylab was in orbit 1973 to 1979, and famously Skylab came down with bits of it being distributed across Western Australia. You might remember all that.
Yeah, I do. We played Skylab Lotto.
As to where it was
we had a map of the world, and we divided it up into grids, and we sold off little pieces of the map, and whoever had the piece where Skylab landed won the pocket of cash. And my brother won. My brother won. Yeah, it was totally illegal.
I was going to say, I take it that wasn't part of the ABC at the time.
Oh, no, look, we were only kids. I was about 11.
Good on you.
Yeah. See, bad influence.
Yeah. Anyway, but Skylab, not only was it coming down an interesting story, but going up was an interesting story as well, because when Skylab was launched, it was actually launched without a crew. It was basically a rocket body that was converted to allow activities inside to provide an orbiting.
Was it a Saturn V, and is there truth to the rumour that it was actually Apollo 18, purportedly?
That could well be the case, because what happened was they launched the body of Skylab, and then a crew was sent up. And one of the first things that the crew had to do was essentially fix Skylab, because apparently a shield that was part of the protective shield of Skylab tore loose during liftoff. So they had to kind of provide another one, and so
they put a tarpaulin on it,
something of that sort. I don't think it was very different from that, actually, but I think it was probably made of Kevlar or something like that.
Maybe.
To withstand extremes of temperature and micrometeorites and things of that sort. So Weitz, Conrad and Kerwin, two other great names of astronautics, basically flew to the Skylab space station on the 25th of May, and it was indeed in an Apollo command module. I think that was why a lot of these 1970s experiments were carried out, to actually use up the Apollo modules that they had, because there was another experiment called Apollo Soyuz, which was a joint joint flight with the Russians. All of these things took place. Anyway, they did that successfully and fixed it up, and that was very good. There's a very nice account on well-known websites of what Paul had to say about the mission. But he's also well known because he was, I think, the third. Let me see. No, was it the first flight? It was one of the early Challenger flights.
Space shuttle.
May have been. Yes, that's right. It may have been the first flight. Yes, it was. He was the first commander of Challenger.
Wow.
That was in April 1983. He's actually 51 by then. So, that's for astronauts is senior age. But of course, there are now.
Yeah, they didn't check the use by date on his uniform.
There are now many examples of older astronauts.
Of course.
Most recently being Peggy Whitson, who was a record breaker very recently. Anyway, first Challenger flight, very successful, a 5-day mission. But sadly, of course, the Challenger is a few years later. Actually, 3 years later. It was in April 1986 when Challenger was destroyed.
I just as a side note, I only had just met my wife, or wife-to-be, around that time, and I was getting to know her and her family, and I was having a chat with her sister one day, and we were talking about the space shuttle program, and I said, probably not a couple of months before the disaster, I think they're getting a bit too gung-ho, something terrible's going to happen, and I just said it tongue-in-cheek, and then all of that unfolded. And next time I saw her, she just looked at me and shook her head. We both knew what we were thinking.
It's a serious reminder, and of course Columbia too. In 2003, serious reminders of the fact that space is very unforgiving, and space flight is
dangerous place.
A risky business. That's right.
Yep.
Just one footnote though to Paul's career. He may well have been an Apollo crew member going to the moon if the lunar missions had not been cancelled in the early 70s. It's thought that he was slated for going up on Apollo 20 had that happened. So, as you know, Apollo 16 was the final one. But there were, I think, 4 more planned, and he would have flown probably on Apollo 20, which I guess he was probably pretty disappointed at.
I think he would have been. It wasn't 17 the last one?
I beg your pardon, 17. Yeah. It's not. Yeah.
And it was one of the most successful too, because they took a geologist with them who almost stupidly ran out of oxygen because he spent too much time on the surface.
That's correct, yeah. I'm sorry, I was doing my arithmetic wrongly and, of course, neglecting Apollo 13.
Yes, which didn't quite make it. But that was one of the great failures/success stories in Apollo history as well, yeah. It's fascinating. Great people, and people like this. Paul Wheats should not be forgotten for what they did. They were pioneers, and what we have today in terms of space technology is a credit to people like him.
Exactly.
Yeah. Exactly. You're listening to Space Nuts. Andrew Dunkley here. Fred Watson there.
0G, and I feel fine.
Space Nuts.
Last but not least today, Fred, a listener question, and this one's a really intriguing one, and somewhat complicated, probably because I just don't understand it. But this one comes from John Milton in Sydney. Thank you, John. He says, I've been thinking about Tabby's star. So it's not a Dyson sphere, but it can. But if we can detect a special character or spectral characteristics similar to what a Dyson sphere would produce, does that imply there are no Dyson spheres detected in all the stars imaged via Kepler? Can we infer anything useful from that yet, or have too few Kepler objects been analysed? You'd think that in 13 billion years, across 13 billion light years, someone would have managed a Dyson sphere or two. Is it just a matter of time until we spot one? My first and most obvious question, Fred, is what's a Dyson sphere? I know we've talked about them before, but I completely forgot.
So it's a hypothetical entity, Andrew. So if you imagine an advanced alien species on a planet in orbit around a star, and extrapolate what we're trying to do to a higher level. What we're trying to do is utilize the energy of our star to satisfy our energy needs. And we do that via, we do it with solar panels. We do it indirectly with wind turbines as well, because the winds are driven by our star, the sun. So we are trying to bleed off energy from the sun. And so if you extrapolate from that and think about what a mega advanced civilization might do, they are absolutely rapacious in their energy demands. And so what they want is to get all the energy from the parent star, not just little bits that fall on solar panels and things. You want to get everything from it. And so what do? You build a structure around it. You build a structure that absolutely envelops the star, probably at the distance of your planet, something like that. and gather all the energy of the star. And then maybe you've got some trick of being able to use that to propel yourself faster than the speed of light across the galaxy and all the rest of it.
Wow.
The kind of things that we hypothesize advanced civilizations might do.
That's a lot of Lego or Meccano, really.
Well, yeah, actually, you don't use Lego.
Really?
It tends to take too long. So we don't know what they use.
No.
But so Dyson spheres have been, they kind of have made the transition from science fiction to scientific hypothesis, and people do wonder whether they exist. Now, the reason why they're raised in this context, and I'll come back to Dyson spheres in a minute, is that there is a star whose formal name is KIC 8462852, but is usually called Tabby's star, or sometimes Boyajian's star, because the lead author on the paper that pointed it out is Tabitha Boyajian. And so that star is curious. It's one of the stars that has been observed by the Kepler space probe. Kepler is a mission which was basically launched by NASA a few years ago to look for planets around other stars, and it's been incredibly successful. So what Kepler does is it stares at about 150,000 stars and looks for dips in the brightness that signify that a planet is passing between the star and ourselves. Mm-hmm. And that's all very well organized, and everybody understands all that and the planets. I think there are something like 3,000 planet candidates that it's turned up, of which about 2,000 have been confirmed. It's very, very successful in terms of discovering planets. But they turned up this object, number 8462852 in the catalogue, otherwise known as Tabby's star, which has dips in brightness that are staggeringly large. For example, let me put it in context. If you were observing the sun with Kepler, when Jupiter passed in front of the sun, it would drop the sun's brightness by 1%. And Jupiter is the biggest planet in the solar system.
Yeah.
But Tabby's star shows irregular changes up to 22%.
Wow.
So that's, it's a significant fraction of the brightness of the star that is being dipped. I think there have been secondary dips as well, which are not quite as big as that, but 22% is the large dip, and so a lot of hypotheses have been proposed for what that might mean, what it might be that's actually causing this. It's clearly not a planet, because a planet which obscures that much of the light of a star is basically the size of a star almost. It's because we know what type of star this is, so we could work out how big a planet it would be to obscure 22% of the light, and it's just too big. It's something that's of star mass rather than planet mass, and it's not there. There are all sorts of other weird things about it. There is a gradual decrease in the brightness of the star. There are other dips that are smaller than the huge 22% dips, and there isn't really an obvious astrophysical explanation for it.
Not a gas cloud or something?
Well, people are certainly talking about dust clouds.
Yeah.
An uneven ring of dust is one of the explanations, and that, I think, is a pretty likely one. People have speculated that it might be swarms of comets that are also obscuring the light. It's not really settled. There is research that is being done now which is making predictions about what you might see in the future. So if it's a ring of dust, and it goes around, there's a big thick blob that takes 22% of the light away, that's going to wind up coming round again at some point, and you can kind of do some calculations that might let you predict when it would be. And that
so if you've got continuity, then it sounds like a regular event then, doesn't it?
That's
it sounds
right.
like something predictable.
And you can analyse it, that's right. But I guess the off-the-wall explanation that has been proposed is that what we're seeing here is actually a Dyson sphere under construction, so that there is part of this structure that is obscuring the light, 22% of the light of the star. That is not accepted by scientists, and the reason for that is that a Dyson sphere itself has a signature, because it will not, it absorbs the light from the sun, from the star, converts that to electricity or power or whatever you've got. But there is a residual infrared signal which would come from the Dyson sphere itself, because the Dyson sphere actually will emit heat. It's inevitable that it will emit heat. We see that as infrared radiation. We can measure that very accurately. And what we measure from this star does not fit the bill. So it's not a Dyson sphere. And just going to the question that we've been asked, of the 150,000 stars observed with Kepler, I don't think any of them have an infrared signal that you could point to being due to something like a Dyson sphere. We've never seen one. We've never seen evidence for a Dyson sphere, which suggests that perhaps they are a construct of our imaginations. And that kind of doesn't surprise me, just in the terms that we were that were mentioned, that we've got a universe that's 13.8 billion years old. It's very, very large. It's got 2 trillion galaxies in it, each of which has about 100 billion stars. We tend to think that there are certain inevitabilities that might lead to. In other words, people like ourselves, we want to believe that the universe is full of aliens. But the bottom line is, when you look at the processes that are needed actually to kick off multicellular life, it's a very, very rare event indeed. It's only happened once on the Earth
that
in
we
its
know
4.6
of, yes.
billion year history. That's right. So it's no surprise to many of us that we haven't seen any Dyson spheres, but it is a nice idea, I have to say. It's a very nice idea.
And thank you to John for posing the question, because it does make for some interesting debate. Although I don't suppose you could call it a Dyson sphere, but in science fiction, they did create the Death Star, which could absorb the energy of a star and then deliver it to destroy a planet. So that would be the nearest thing to a Dyson sphere in science fiction, I imagine.
Indeed, that's right. And yes, the Death Star is it's science fiction. That's right.
It is. But, the odds of ever finding anything as incredible as a Dyson sphere must be extremely low to almost zero.
Yeah, but just having said that, Andrew, the Earth is festooned with telescopes of many, many different kinds, and we now have the ability to observe gravitational waves from space, albeit that's a science that's still in its infancy. So we are always on the lookout. There are surveys going on for galaxies and stars and quasars and all these things. And one of the interesting things about surveys, where you're observing many, many objects, it's not just about doing like census studies, it's also about turning up the oddballs. And so if there is something odd out there, there's a really good chance that we might find it. And that's one of the things that keeps us going, because the excitement of what might be just around the corner.
Indeed. We watch with interest, as always. Thank you, John, for the question. We certainly do encourage you to send us your questions. We've got a bit of a backlog, so we'll get to all of them when we can. But, yes, definitely send us your questions on Facebook or Twitter or I don't know how else we can get it. You could send me a text.
Well, letter in the post,
Yeah. Oh, that's novel. Yeah. But look, send us your questions. We'd be happy to give them a bit of a shot. Fred, as always, thank you. You keep us interested and entertained, and we thank you for that. And we look forward to talking to you again very, very soon.
Sounds great, Andrew. Take care, and we'll speak soon.
Fred Watson from the Australian Astronomical Observatory, and thank you for listening. Don't forget to listen to our sister podcast, Space Time with Stuart Gary. You can find that on most podcast distributors. Until next week, thank you for listening to Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.